What is up everyone, my name's Jared Beckwith, and if you missed last video where I created the world's simplest neural network from the textbook Grokking Deep Learning by Andrew Trask, here's a little quick recap. It's a 2-neuron neural network. Pretty much what we wanted this neural network to do is to take an input, which was the number of average toes each player on a baseball team has, times the weight will give you a prediction of their win percentage. Now, if you're thinking the number of toes isn't exactly the greatest predictor of win percentage, that is correct. Now, if we want to take this neural network one step forward, we're going to add more inputs, such as win percentage and number of fans. So if we take the average number of toes, the average win percentage, and the number of fans, and you use those 3 data points in order to make a more accurate win percentage prediction. Okay, here's a copy of our upgraded neural network. We went from 2 neurons last time to now we're at 4. We have 3 inputs giving us 1 prediction. So the first input is the number of toes, which is 8.5, win-loss record, which is 65% or 0.65, and also the number of fans in millions, let's say 1.2 million fans. Now the way to calculate this prediction is very similar to the last one, only we're going to add addition. In the last one, it was just a multiplication. 8.5 times 0.1 would give us 0.85. So we have 0.85, and then we have to do the next step, the win-loss record. Take that into account. 0.65 times 0.2 gives us 0.13. And then the last step is the number of fans, 1.2 times 0 gives us 0. Okay? So all we have to do is add up this prediction plus this prediction plus this prediction, which gives us 0.85 plus 0.13 plus 0 gives us a 98% chance of winning. This is just the basics pretty much of taking multiple inputs and wanting the neural network to give us 1 prediction. Now the other tutorials that I've seen on YouTube for beginners, they start out with a 13,000 input neural network. To me, that's way too complicated, especially if you're not an expert in Python. I'm definitely not a Python expert either, so let's keep things as simple as possible. For example, I started out with a 2-neuron neural network, now we're up to 4 neurons. The 2-neuron neural network only took 9 lines of Python code, which in the book, in the textbook Grokking Deep Learning by Andrew Trask, he said to memorize that one before you move on to this 4-neuron neural network. So if you haven't memorized that yet, I'll put the link in the description to my last video. Make sure you memorize that. And now we're going to jump into the code of this 4-neuron neural network, and we're going to keep on building up to that 13,000 input neural network, and you guys are going to see it's going to be working magic. Alright everyone, here's a copy of the code. It's 12 lines. I'm just going to go through it step by step so you're not lost. I was definitely lost when I first seen this, so let me break it down for you guys. So the first step is to import NumPy as NP. Now NumPy just stands for numerical Python. It's going to help us do some operations, the multiplication and addition, very easily. So the next step is to initialize the weights variable. Weights equals np for numpy dot array. Now the word array, don't get tripped up by that. An array is just a list of things that are of the same data type, and we're just using numbers. So np dot array, remember it's just a list, don't be scared. np dot array, these are our 3 weights. Remember the first weight was 0.1, the second weight was 0.2, and then the third weight we did was 0. Now the next step is we have to define the neural network. Some of you guys, if you watched the last video, this will seem very familiar. Input, comma, weights, and we put a colon, and remember our prediction is equal to input. Now this input dot weights, that's called a dot product. That's just a fancy term for the weighted sum, which is just multiplying the weights times the inputs. Nothing crazy, just what we were doing on the whiteboard. They just have a different name for it, which is a dot product. Input dot weights remember, input times the weights and just add them all up. Easy enough. And then return prediction. And then the next step is to initialize the toes variable, np.array, remember just a list of the example we used was 8.5 toes. Now let's say the next game it was an average of 9.5 toes, and then the next game it was an average of 9.9 toes, and then the next game it was an average of 9.0 toes. Next we do the win-loss record is equal to np.array. They had for the first game they had a win-loss record of 0.65. We'll do 0.65, and then the next game they had a win-loss record of 0.8, and then the same for the next game, 0.8, and then the next game 0.9 for the win-loss record. And then next we do number of fans. This is number of fans in millions. Same thing, np.array. First game we do 1.2 million fans, and then say 1.3 million fans, 500,000 fans, so 0.5, and then let's say 1.0, so a million fans even. Okay, now that we have the empty 4-neuron neural network and we also have all the different variables, we have to give it an input, which we decide whether we want to do the input for the first game, the second game, the third game. So we're just going to do the first one the same as we did on the whiteboard. So input equals np.array. We're going to do the number of toes. It's going to be 0. 0 refers to this, because in programming you count 0, 1, 2, 3. 0, 1, 2, 3, 0, 1, 2, 3. So we're going to be using 0 for all of these. So number of toes, and then we wanted to do win-loss record equals 0, and then we wanted to do the number of fans, and we're going to do 0 for that one as well. Next, we have to do prediction equals neural network. This is very similar to the first one, so make sure you memorize the last video's code, link in the description. Input, comma, weights. And then the last thing we do is print the prediction. Now, what do we get? We get a 98% chance of winning. Now, if you wanted to change up the input, the different things, if we wanted to put 1, 1, and 1, we would be feeding the input of 9.5, 0.8, and 1.3. So it would be 9.5 times 0.1, 0.8 times 0.2, and 1.3 times 0, and you would add all that up, and that would give you the prediction. Very simple, guys. This is the 4-neuron neural network. If you guys want to see what will happen if we have one input and we want to have 3 outputs, so the same thing as this one, only we, instead of 3 inputs and 1 output, we do 1 input and 3 outputs. Make sure you subscribe. That's going to be on the next episode, episode 3. Make sure you subscribe. We're going through the simplest of simple neural networks here on this channel. My name's Jared Beckwith, and if you want to learn deep learning, machine learning, artificial intelligence, all that jazz, make sure you subscribe. I will see you guys on the next video.